Good morning, students. Welcome back to my channel. Today we'll be looking at the topic continuity of a function. A function, a function f of x is said to be continuous at at the point x naught if one if f of x naught exists if f of x naught exists. So I will tell you the meaning of these properties once we're done. So if the limit of f of x as x tends to x naught exists, okay, and the third condition is that the limit of f of x as x tends to x naught equals f of x naught. So if these three properties are satisfied, then we say that the function is continuous at the point x naught. Okay. So suppose one of these properties failed, then we say that the function is not continuous, and therefore we say that it is discontinuous at that point x naught. All together. Okay. So we'll take an example on this and tell us the meaning of f of x naught being like this. So it means that it has a finite value. It has a finite value. This one also exists, means that it also has a finite value. And then if the two are now equal, and then we say that the function is continuous at that point. It's possible that this exists and this exists, but both of them are not equal. Once they are not equal, it means that it does not satisfy the last one. Therefore, it's still not continuous at that point x naught. Okay. So let's take an example to illustrate this. The example on the board, we have to examine the continuity of the function f of x equals to 4x plus 5 over 9 minus 3x at x equals to minus 2 and x equals to 3. Okay, so let's look at the first one. All we need to do is to check the three properties for this. Okay, so let's take the first one. When x equals to what? X now. So we want to look at the continuity. So it's the first property 1. F of, what will you check now? What our x naught in this case? So minus 2. Our x naught in this case is the minus 2. Are we together? Okay. So f of minus 2 for this function will be, wherever we see x, we replace it with minus 2. Okay. So that we have 4 times minus 2 plus 5, right? Divided by 9 minus 3 times minus 2. Okay. Let's simplify this. 4 times minus 2 minus 8 plus 5, I mean, divided by 9. Then minus 3 minus 2. Minus 3 times minus 2 will give you plus 6. Beautiful. Okay. So minus 8 plus 5. Minus 3. Okay. So we have minus 3 divided by, okay, 15. Beautiful. Okay. Simplifying this, what do we have? That will be minus 1 over 5. Excellent. Excellent. Now, let's check the second property. Second property, we have to find the limit of f of x. F of x is 4x plus 5 divided by 9 minus 3x. Okay. As x tends to x naught, our x naught is minus 2. That means as x tends to minus 2. Do you have any question? Okay, so let's now, how do we take this limit? Recall our last class, I said the limit of, recall, the limit of f of x as x tends to a is equal to f of a. Okay, so for this we have to substitute wherever we see x, we substitute minus x, minus 2, right? Okay, so to do that, you can have 4 times minus 2 plus 5 divided by 9 minus 3 minus 2, Abi. So clearly that will give us the same thing as what we have there, Abi. That will be minus 1 over 5, right? Okay, so clearly we can see that, so property 3, we have that the limit of 4x plus 5 over 9 minus 3x, x tends to minus 2, is equals to minus 1 over 5, Abi, which is equals to our f of minus 2. Okay, so therefore f of x is continuous at x equals to minus 2. So now your turn for x equals to 3. So we check the first property. Yeah, so what do we do for the first property? So we find f of 3. Okay, so what is f of 3? We have 4. Okay, that's 5 over, okay, 3. Okay, so what will this give us? This is 12, 5 again, that's 17 over, okay, over 0. That is 9 minus 9, right? Okay. So, and what we have here is what? This is undefined. And that means this does not what? Does not exist. So once one of the property fails, once it fails, then we know that the function is not continuous at that point. So we say that therefore f of x is discontinuous at x equals to 3. Now, if we have this particular question being framed in another way, I ask you to find the point of discontinuity of the function f of x. Okay, so let's say another way the question can be framed for discontinuity. So that we can find the point of discontinuity of f of x equals 4x minus 5 plus 5 over 9 minus 3x. So if you have this kind of question, all you need to do is to find the value of x that makes the denominator equal 0. Exactly. So if you have to find the point of discontinuity of f of x, of any function, so if it's a rational function like that, you just need to find the value of x that makes the denominator equal 0. That's fine. Okay, so all we need to do is to say that 9 minus 3x equals 0, right? So from here we have 9 is equals to 3x, right? Which means the same thing as 3x equals to 9, right? Then we can divide both sides by 3. Good. So we have x is equals to 9 divided by 3, and that means x equals to what? 3. So that gives you the point of discontinuity. Okay. So let's look at this example here. Examine the continuity of f of x equals to x squared minus 1 over x minus 1. Okay. So what's the first thing we do? Let's quickly check the first property. We want to check f of 1. Okay. If we check f of 1, we're going to have 1 squared minus 1 over 1 minus 1, which is equals to 0 over 0. Okay. So if you look at this, this is 0 over 0, which is what? Indeterminate. We say that this one is indeterminate. Okay. So what this implies is that this particular function can be written in another form. Are we together? Okay. So we now redefine the function and then now apply. Because if you look at this one, it means that this function is not continuous at x equals to 1 because it's filled with the first property. This is indeterminate. Okay. So the next thing we now do is to redefine the function. Okay. We now redefine this way. That's okay. Our f of x, which is equals to x squared minus 1 over x minus 1, can be written as, if you look at what we have here, we have x squared minus 1 squared. Remember that 1 squared is still the same thing as 1 over x minus 1. Okay, so what we have here now, we are having difference of 2 squared. This is the square, this is another square. So we recall that anytime you have that, recall that a squared minus b squared is equals to a minus b times a plus b. If you wish, you can write a plus b first, then multiply by a minus b. You can write this a plus b multiplied by a minus b. Okay, so here now, our a is x and b is 1. So we can now write this as x minus 1 multiplied by x plus 1 divided by x minus 1. So x minus 1 will take care of x minus 1, and what we have left as that function is what? X plus 1. So with this our redefinition, we now have that f of 1 now will be equal to 1 plus 1, which is equal to what? 2. That is the first property. Second property, we take the limit as x tends to 1 of f of x. And what is our f of x? X squared minus 1 over x minus 1. We have redefined this. This means the same thing as the limit of x plus 1 as x tends to 1. Are we still together? Okay. So now, wherever we see x, we substitute 1, so that we have 1 plus 1. So observe that anytime I want to substitute, I don't write the limits again. Okay, so 1 plus 1, that gives you what? 2. So clearly, we will see that the limit of f of x as x tends to 1, which is equal to the limit of x squared minus 1 over x minus 1 as x tends to 1 is now equals to 2, which is equals to equals to 2, which is equals to f of 2. Is this 1? F of 1. F of 1. After we redefine the refined form of the function, okay?